everyone. I am Supriya Cholla. I have been doing internship at Abhyaz for the past 4 months. Uh, I'm going to give webinar on digital electronic flip-flop introduction. Introduction on flip-flops. Flip-flop is a sequential circuit which generally samples its inputs and changes its output only at the particular instant of time. That is the discrete instance of time, which is not continuous. And flip-flop can be either said to be edge-sensitive or edge-triggered, whereas latch is said to be level-triggered. To understand the basic flip-flop, we need to understand what is a combinational circuit and what is a sequential circuit. To understand that, is a combinational circuit means from that logic circuits from the digital systems, we can create a lot from the logic gates is said to be a logic circuit, which in turn the combination of logic gates gives us the combinational circuit. A sequential circuit is said to be the combination of the combinational circuit as well as with the hint of the storage elements, and that storage elements are said to be the flip-flops. Because the state of the storage element is a function of the previous inputs, and the output of the sequential circuit depends both on the present and the past of the input in the sequential circuit. That is, which totally depend upon the time sequence of the inputs and as well as the internal states. The block diagram of the combinational circuit here, it will be taken as the n inputs which give the combination of m outputs. And the m output is the 2 power n input, as we know the basic 2 power n combinational circuit of the logic paths. Here there is no feedback path as well as the no storage elements in the combinational circuit. What is a feedback path is? A feedback path is a connection from the output of one gate to the input of the second gate, that is, whose output forms part of the input to the first gate. Here we can see the block diagram of the sequential circuit. Here with the combination of the combinational circuit and the memory elements, which in turn gives the output from the given input. Sequential circuit, however, acts as a storage elements and has memory. They can store, retain, and then retrieve information even when the later time. And the storage elements here stores in the binary format, that is 0 and 1. The binary information stored in these elements given at the definite states of time in the sequential circuit. Types of sequential circuits. We have two types of sequential circuits. Here one is the synchronous and other is the asynchronous circuit. A synchronous sequential circuit is a system whose behavior depends upon the discrete instance of time, whereas asynchronous sequential circuit depends upon the input signals at any instant of time. That is, instantaneous time period is asynchronous and discrete instance of time is synchronous. And the storage elements commonly depend upon the time delay devices. That is, the propagation of the delay is important in the storage capability of time delay device. Synchronous clocked circuit. How a clock is majorly plays a vital role in the circuits. That is, in the sequential circuits, which in turn helpful for the flip-flop generation, that is to combinational part of the registers. The clocks generally are the active high or active low. Active high in the binary format, we triggered it as 1, and active low, we could call it as 0. And the clock pulse here generates a different various of active high and active low pulses. Whereas if you connect a circuit in asynchronous format, it will give as instantaneous time clock pulses, so that the output depend upon the instantaneous variations of the clock pulses. Whereas in synchronous, it depends upon the discrete instance of time, that is, the clock pulses varies at discrete instance of the time. The clock signal is commonly denoted as CLK or clock, which has a periodic train of clock pulses. What is the purpose of a flip-flop? The storage element in clocked sequential circuits are known as flip-flop. So the basic storage elements, that is the memory. A flip-flop is a volatile generation which has binary storage device that capable of storing 0 and 1 bit of information. So you may ask, what's the size of the flip-flop that it can store? Is the 1 bit. And as we can say, we are using the term memory. That means it is volatile. Even the power is switched off, it can store the information from the past values. As far as you learned from the past combinational circuit, it doesn't do that, because combinational circuit has no storage elements, while the sequential circuit has flip-flop, the storage elements, so that it could remember the past instant value time by the clock generations. What are the latches and flip-flops? What is the basic main difference between the latches and flip-flops? Basically, latches and flip-flops are same. The major difference between them is one is the clock transition and other is the signal transition. That is the variation of the clock pulse generation transition, which entirely depend upon the time delay or the propagation delay that we used in the system or device that we going to make in the circuits. So the two types of storage elements are related, because latches are the basic circuits. From the basic circuit of the latches, we can construct the flip-flops. Although latches are useful for storing the information, such as the flip-flops too, as the binary information, and we can design a synchronous sequential circuits, which are basically not practical for use when we use the latches, because their binary information storage is so not applicable, while it may give an invalid in certain occasions while doing the practical scenario. So we generally use the flip-flops, that is the clock transitions. Storage elements of flip-flops has a positive edge, negative edge, because the flip-flop is also said to be the edge triggered. That means when the edge at the edge point of the clock transition, the flip-flop output is generated. The momentary change is called trigger, and the transition it causes its step is said to be the triggered the flip-flop. The response of the positive level is shown in the A, and the positive edge, that means at the positive edge trigger, that is when the output is derived. Here at the negative edge, that is when the negative output is derived at the negative edge pulse. So there are basically 4 type of flip-flops generally said: RS flip-flop, D flip-flop, JK flip-flop, and T flip-flop, and there would be conversions and excitations of these flip-flop. So the basic flip-flop is said to be RS flip-flop, which is reset and set flip-flop. As we can see the diagram, here active high is given to the set and reset values. That is the predetermined value here given. You either can give the active low or active high. So the RS flip-flop is the most basic sequential flip-flop. As we know that flip-flop bit storage energy is 1 bit, and it is also a bistable cross-coupled device. As we can see this picture, the Q output is given to the B of Y NAND gate, and Q bar is given to the input of A to the X NAND gate. That is known as the feedback path, as we have discussed earlier. And the Q and Q bar is said to be the outputs, and S and reset are said to be the inputs that given from the feedback path. As we need to understand, the clock is generated and the clock is also given as high, that is edge triggered, or positive edge or negative edge, that means high low or high we can give. We can implement through universal gates such as NAND or NOR gate implementation, which will help the active low inputs. The two NAND gates are to be cross coupled such that the output NAND 1 is fed back to the input of NAND 2, and output of NAND 2 is fed back to the input of NAND 1, which is nothing but the feedback path, and the remaining inputs of NAND 1 and NAND 2 are given to the S and R inputs, such that the outputs of NAND 1 and NAND 2 are Q and Q bar. Such as the same active representation for the active high, instead we here give directly, not to the S and R, because S and R are directly fed to the active low. to, instead of turning that active low into active high, we need to keep a NOT gate as mentioned here. The clocked RS flip-flop is the clock generation of active high and active low, so that the flip-flop could be level triggered or edge triggered at any occurrence of the clock pulse according to the output change states present from the input. Here you can see the basic representation of the RS flip-flop, how we can construct an RS flip-flop. Here we are using two NAND gates, and then we have to select an LED. What is the primary use of LED here is to LED, if it is glowing, that means output is high. If LED is not glowing, that means output is low. Output is high means that is the binary representation of 1. Output low means that is a binary representation of 0. So that's why we are arranging LEDs here to understand the SR latch outputs. And we are also constructing with switch. Here the basic switch is provided to the each gate, because whenever the one bit we need to provide, we need to connect it to the switch so that it could be applicable whether the SR latch is working or not. In order to switch can work, we need to also connect the switch with a voltage signal as well as ground. If the one bit is used, we need to provide the high voltage signal, and if we need it as a 0, that means active low, we need to give it as ground. So for the each NAND gate, we need to provide the voltage source as well as the ground. And for the LED, in output source has to be connected to the ground too. And we need to connect all these switches according to the input level. And then we need to represent whether the LED is glowing or not glowing, so that we can do the simulation, and from that we can provide the SR link outputs, that is Q and Q bar outputs. If the NAND gate is on, that means it is the high, and here the second NAND gate is low because we are directly connecting it to the ground, and so such that the LED is either glowing, that is the output could be Q, could be 1. If it is not glowing, the Q could be 0. Now the second flip-flop is JK flip-flop. JK flip-flop work in the same way as SR flip-flop, but the major difference between those two flip-flop is the set generation. Here the set, the both SR flip-flop is set to 1, so such that the circuit provides invalid states to the outputs. But in JK flip-flop, there are no invalid state, even if the set is generated to be 1. The input of a clock is 0, that is low state. What could be the output of JK flip-flop? Here, if you could give the JK flip-flop, as I am showing in the diagram, is the active low. If the NAND input could get 0, that means no other input is not necessary. What is the NAND gate? Basic information is like the NAND gate, if it is 0, 0, the output could be 1. If it's 0, 1, 1, and 1, 0, 1. 1, 1 is 0. So if we could take the previous value of the NAND gate, that means the output of Q. If any input NAND gate is 1, the second input is necessary. So we are taking the previous input is 0. If it is Q0, the Q bar could be 1. So what could be the feedback line? It is 0, 1. According to NAND gate, 0 and 1 could be 1. And if it is 1, the NAND gate 1, 1 could be 0. Same, if the previous value, in order, here also the active low combination, but at the last time we took the previous value as 0. Now we are taking the previous value imaginary as 1. If it is Q1 and Q bar is 0, 1, 1 of NAND gate is 0. If it is 0, the feedback path, and 1, 0 of the NAND gate could be 1, such that we can write the outputs of the JK flip-flop in active low combination, such that we can also view if there is active high also. That means the clock could be generated as high pulse 1. now only explained about the active low inputs. These are the truth table of the active low input of the JK flip-flop. That means the preset and clear inputs. Whereas in SR, the S set to be set and R set to be reset. Whereas JK, we use the terms like preset and clear for the asynchronous or synchronous, which means that they will have immediate effects on Q and Q bar. That means there are no invalid options regardless the state of the clock. The preset input are usually directly put at 1. That means the set is directly always 1 and clear is 0, such that Q and Q bar has no invalid inputs. And D flip-flop. D flip-flop is a better alternative and very popular in digital electronics. They are commonly used for the counters and registers and input synchronization. They are commonly in the D flip-flops, the output can be changed by the clock edge. That means here only the D, there are no two inputs, only the D clock input as well as the clock input. And the clock input is always the bar of the D. If D is 0, the clock would be 1. If D is 1, the clock would be 0, such that the outputs, the previous values could be taken as 0, 1 or 0, 1. That means Q here acts as also an input, which gives the Q bar as output in value triggeration. The change of the state depends upon the rising edge of the clock. And if you want to talk, we need to talk about the state of the machine, then we could talk about the FSM, that is finite state machines, which in turn the another topic of Mary and measly state machines, such that we could create another input clock versions. And T flip-flop. T is toggle flip-flop. Toggle flip-flop is like a JK flip-flop, but it is a single input version of JK. That means T acts as the input. If you take T as 0, that is Q input as 0, the output could be of the NAND and OR, such that it would enable the output as 0. These flip-flops are the ability to complement their state of the machine, and it is the modified version, so the output could be as XOR. Application of these flip-flops can be used in frequency devices, counters, storage registers, shift registers, and many more. You may ask, what is a register? The combination of two or more than two flip-flops is said to be a registers, and the function of the register is said to be a buffer, and the storage registers should be the storage, and we have shift registers. We have different type of shift registers, that is left shift register, right shift registers, etc. And as we all know, the major application is storage of data is known as the flip-flop, and also this data can be transferred. Conclusion: flip-flops and latches are used as data storage elements to store a single bit of data, and one of the which it can store 1 bit information, and it stores in the binary format, that is 0 and 1, and that data can be transferred, can be used to store of a state and the circuit, which is described as a sequential logic in electronics. Thank you.